Hello students, in today's class we will be discussing about the remaining concepts in the emerging trends chapter. So first we will be discussing about Internet of Things, followed by Web of Things, cloud computing, grid computing, and about the blockchain technologies. So let's start the class to discuss about these concepts in detail.
Internet of Things. So the term computer network we commonly refer to as network of computers. So network of computers means the network consists of a laptop, a desktop, a server, a portable device like tablets, smartphones, smartwatches. So everything gets connected through wired or wireless. So that represents the network of computers. So network of computers means not only there is a particular gadget, but the multiple gadgets and many different types of gadgets connected together through a wire or wireless connection. And we can communicate between these devices using the internet or LAN, that is a local area network. Now just imagine if all the bulbs, fans and refrigerator which we have in our home, it becomes a part of this network. What will happen? How they will communicate with each other, and what will happen if they communicate with each other. Just think about the advantages and the task that can be accomplished if all these devices with smart connectivity features are able to communicate among themselves, and we were also able to communicate with them using computers or smartphones. So the Internet of Things. So Internet of Things is nothing but it is a network of devices, yes, that has an embedded hardware and software to communicate with other devices to exchange the data. So what is the reason behind communicating with the other devices? So the only thing is to connect and exchange the data. So that is the main purpose. And present, if you see in a typical household, many devices have advanced hardwares and software. So hardwares in the sense like microcontrollers. And these devices, if you see, it actually doesn't need maximum human intervention for operations. So these Internet of Things actually, it brings together these devices to work in collaboration, and it assists each other in creating an intelligent network of things. Just take an example of a microwave oven or an air conditioner, a door lock, a CCTV camera, or any other devices which has been enabled to connect to the internet, and we can access all these devices and we can control everything remotely on the go by using our smartphones. So it is possible by making use of our smartphones to control all these devices from the remote handling. Yes. So these things comes under Internet of Things. And followed by that you have this particular picture explains how Internet of Things connects all the electronic devices together, like smartphones or the remotes, and then the house door locks, then tab or else the electronic devices like the bulbs, fans or the flights, computers, a CCTV camera, how all these things are connected together by using a smartphone. That has been represented here in this picture. And about Web of Things. So when it comes to Web of Things, there is a difference between Internet of Things and Web of Things. So Internet of Things, if you see, it allows each and every devices to interact with other. Yes, it allows to interact with different devices through the internet with the help of smartphones or computers by just creating a personal network. But to interact with n number of devices, so to interact with all the devices which we have in our home, we need to install n different applications. So that would be convenient, that wouldn't be convenient at all to have one interface to connect all the devices. So the web, if you see, it is already being used as a system to communicate with each other. So it will be possible to use the web in such a way that all the things can communicate with each other in a very efficient manner by integrating them together. So that represents a Web of Things. So it allows the use of web services to connect anything in the physical world besides human identities on the web. And it also paves way for creating smartphones, smart homes, smart offices, smart cities, and so on. So sensors, when it comes to the topic of sensors, everywhere, even the phone which we are using, it works based on the sensors. If we touch, it is responding to whichever application we are trying to open. It is responding to the PIN numbers which we are providing during the banking transaction. So everything works with the help of sensors. Yes, so in our mobile phones we have these sensors. So what happens when you try to hold your mobile phone vertically or horizontally? So the display also changes eventually, right? According to which way you're holding your mobile phone. And it is actually possible because of the two different sensors. One is called the accelerometer and the other one is called gyroscope, gyro. So accelerometer sensor, if you see, which helps to detect the orientation of the phone, whether you have kept your phone in the landscape mode or else in the portrait mode. So that represents the orientation that will be detected by the accelerometer sensor. And gyroscope sensors, if you see, it tracks the rotation or the twist of your hand. So we usually twist our hand also when we are trying to rotate our phone, no? So that adds to the information supplied by the accelerometer. So these sensors, if you see, are very commonly used for monitoring and observing elements in real world applications. So based on the real world applications, the sensors will work. So when we are touching with two different fingers, when we try to zoom a picture, we use thumb finger and index finger. Yes, so these sensors plays a very vital role in observing all the real world applications. And the evolution of smart electronic sensors, actually, if you see, it contributes a larger way to the evolution of this IoT. Yes, and the smart sensor, if you see, it is a device that takes input from the physical environment. Yes, the smart sensor which we have in our phones or any other devices, it actually takes input from the physical environment. Physical environment, if we are using our hand to open an application or else to unlock our phone, so that is the physical environment where it is taking our hands movements as the input, right? And it uses inbuilt or the built-in computing resources to perform the predefined functions based on the input we are going to give, based on which application we are going to choose. It will process it and finally it will display the result. Clear? That is how the sensors will work. Then smart cities. So when it comes to smart cities, with rapid urbanization, the load on the cities are increasing day by day. Developing the city has become a very challenging task in managing all the resources like land, water, waste management, air pollution, health and sanitization, traffic, public safety, security. So everything has become a challenging task nowadays. So to face all these challenges, the city planners around the world, they are looking for the smarter ways to manage and make the city sustainable for living. So the idea of the smart city, if you see, it makes use of the computer and communication technology along with Internet of Things and Web of Things to manage and distribute resources efficiently. So when it comes to smart cities, we will tend to have smart building, smart bridge, smart tunnels. So that is what they have given in this picture. So here we have smart buildings, smart bridges, smart tunnels. So each and every things will have a separate purposes which has been connected with wireless sensors and wireless signals as well. These keys. See here, the square brackets that represents the central computers and these yellow dots represent the wireless sensors, and this diamond shapes, the blue color diamond dot represents the sensor nodes, whereas this represents the wireless signals. So why do we have all these things? When it comes to a smart building, it actually uses a sensor to detect the earthquake tremors and then warn nearby buildings so that they can prepare themselves accordingly. And when it comes to the smart bridges, it detects any loose bolts or cable or crack or any cracks on the bridges will be detected earlier so that the authorities will be getting a SMS alerts. And then smart tunnels, they make use of the same wireless sensors to detect any leakages or congestions in the tunnel. Yes, so that the information will be sent as wireless signals across the network of sensor nodes to a centralized computer for further analysis. So every sphere of life in a city, if you see, like transportation systems or power plants or water supply networks, waste management, so all the fields, if you see, they make use of these wireless sensors nowadays, and hospitals to optimize the efficiency of city operations and services. Then cloud computing. So cloud computing, it is actually an emerging trend nowadays in the field of IT. where the computer-based services are delivered over the internet or the cloud. So all the computer-based services will be delivered over the internet or the cloud for the case of accessibility from anywhere by using any smart devices. So it is not that you have to stick to the computer to share all the resources. You can have your smartphone. Smartphone is much more enough to share all the resources. Yes, that represents a cloud computing. And the services comprise like software, hardware. Hardware means the servers or the databases, storages, all these things comes under the cloud services. And these resources are provided by companies called cloud service providers, and usually they will charge on pay-per-use basis, like the way we pay for electricity usage. So per unit, we have to pay certain amount for if it is for commercial or if it is for residential purposes, right? So similarly, how do we pay the electricity bills? In the same way, if we cross the storage limits, we have to pay to maintain the storage services. So there we have to pay for the cloud service providers. So we already use many cloud services while storing our pictures and files as backup on internet or host a website on the internet. For example, you can take Gmail. For each and every user, 15 GB has been provided. But if we try to cross that 15 GB, we have to make some payment to get additional storage. So this is also one example of a cloud service. So through this cloud computing, a user can run a bigger application or process a large amount of data without having the required storage or processing power on their personal computer as long as they are connected to the internet. So there are numerous advantages of using this cloud computing. When it comes to cloud services, there is a better way to understand the cloud is to interpret everything as a service. You have to consider everything as a service. So a service means it corresponds to the facility that is being provided by the cloud. So what are the facilities that is provided by the cloud? Actually, if you see, 3 different services are available: SaaS, PaaS and IaaS, which is SaaS represents the software as a service, then infrastructure as a service, and then platform as a service. So let's see one by one regarding this cloud computing services. Infrastructure as a service. So if you see here, it offers different kinds of computing infrastructure. So infrastructure, from the name itself, you can understand what are the resources that it can provide as a service. So such as servers, virtual machines, storage and backup facility, network components, operating system. So any kind of hardware or software, all these services are offered by this IaaS. So that is infrastructure as a service. So using this IaaS from the cloud, a user can use the hardware infrastructure located at a remote location to configure, or he can deploy, and even he can execute any software application on that cloud infrastructure. So for that, they make use of this infrastructure of as a service. So they can outsource the hardware and software on demand basis, and they can pay as per the usage. Thereby they can save the cost of software and hardware and other infrastructures as well by maintaining and security. Then platform as a service. So if you see this, with the help of the service, a user can install and execute an application without worrying about the underlying infrastructure and their setup. For example, this PaaS, that is platform as a service, it provides a platform or environment to develop, test and deliver software applications. Suppose we have developed a web application using this MySQL and Python. To run this application online, we don't have to install this MySQL and Python softwares in the cloud. Yes, so we can avail it using the pre-configured Apache server from cloud, which has this MySQL and Python, which is already pre-installed in it. So it is not necessary to install these applications in the cloud. You can directly run this application online. Clear? And we do not have to configure the web server Apache also. And this PaaS, the user has complete control over the deployed application and its configuration as well. So it provides a deployment environment for developers at a much reduced cost, lessening the complexity of buying and managing the underlying hardware and software. Followed by that, SaaS, which is software as a service. So here it provides the on-demand access to application software. So that usually requires a licensing or subscription by the user. So when we are using Google Document, Microsoft Office 365 or Dropbox to edit a document online, we use this SaaS from cloud. So the user is not concerned about installation or configuration of the software application as long as the required software is accessible. So if the software is accessible, you don't have to worry about the installation or configuration. So only when it is not available, you don't have to worry about it. So a user is provided access to the required configuration settings that they are using at present. So in all the above standard service models, if you see, a user can use on-demand infrastructure or platform or software and is usually charged as per the usage by eliminating the need of a huge investment upfront for a new or evolving organization. So according to the usage of the person, we have to pay. Otherwise, it is not necessary at all. Yes. So in order to utilize and harness the benefits of this cloud computing, the Government of India has embarked upon an ambitious initiative which is GI Cloud that has been named as Meghraj. Yes, which is available in the website cloud.government.in. And now about grid computing. So when it comes to grid computing, it is a computer network of geographically dispersed and heterogeneous computational resources. So unlike cloud, whose primary focus is to provide services, grid is more application specific. So cloud computing, if you see, it provides services, it provides a primary focus on the services. But grid, if you see, it is more application specific and creates a sense of a virtual supercomputer with an enormous processing power and storage. Yes, the resources are called nodes, and all these nodes temporarily come together to solve a single task to reach a common goal. And the countless computational nodes ranging from handheld mobile devices to personal computers and workstations are connected to LAN, which is the internet. So it is economically feasible to reuse or utilize their resources like memory as well as processing power. And this grid, if you consider it, comes in two different types. One is the data grid and the other one is CPU or processor grid. So data grid, it actually manages large and distributed data having the required multi-user access. Whereas CPU or processor grid, if you see, it removed from one PC to another as needed, or a large task is divided into subtasks and allotted to various nodes for parallel processing. So if you look at this grid computing pic over here, users are who shares their resources. So grid resource management system, and users share their resources from many different devices over here. It is completely different from IaaS cloud service. So in IaaS, if you see, there is a service provider who rents the required infrastructure, but in grid computing, multiple computing nodes join together to solve a common computational problem. So that is the difference between this infrastructure as a service and grid computing. And to set up a grid, by connecting the numerous nodes in terms of data as well as CPU, a middleware is required to implement the distributed processor architecture. Now about the blockchain technology. So we perform digital transactions nowadays. Everywhere we are performing the digital transactions. So when we perform digital transactions, everything, all the data that has been stored in the centralized database. Yes, the data gets stored in a centralized database, and from that only we are accessing and making the transactions. So each and every transactions that are being updated one by one on the database. Immediately we get messages in our mobile phone, in the net banking. Yes, so immediately it gets updated one after the other. So this is how the ticket booking websites or the banks actually operates. And so all the data is stored on a central location. There are chances of data being hacked or lost. Sometimes this tends to happen. So this blockchain technology works on the concept of decentralized and shared database. So the blockchain technology, if you see, it is actually based on the concept of decentralized and shared database, where each computer will have a copy of the database. So when each computer have the copy of the database, each block can be thought of as a secure chunk of data or valid transaction happens. So when each block has some data called its header, it is visible to every other node. That is, whomsoever is having the copy, it will be visible to every other node, that is the owner. Yes, only the owner will have the access to the private data of the block, and such blocks form a chain called blockchain. And we can define the blockchain as a system that allows a group of connected computers to maintain a single, updated, and secure ledger. Yes, so each computer or a node that participate in the blockchain receives a full copy of the database. So it maintains an append only, that is the open ledger, where when it is updated within the network authentication and the transaction, so it is not possible for a single member of the network to make changes or alter data, because it keeps a copy of the blockchain with all the members. So that is the reason why this blockchain technology has been used. And the most popular application of blockchain technology is the digital currency. So due to its decentralized nature, what happens on this openness and security, blockchains are being seen as one of the ways to ensure transparency, accountability, and efficiency in business. So even in healthcare, better data sharing between healthcare providers that results in a higher probability of accurate diagnosis, so that more effective treatments can be given, and overall increased ability of healthcare organizations to deliver cost-effective care will be provided. And another most potential application of this blockchain technology, if you see, is land registration records. So this avoids the disputes arising out of land ownership, claims, and encroachments. And one more thing regarding the voting system. So this voting system becomes more transparent and authentic, so that avoids the problem of vote alterations. So this can also be used in diverse sectors like banking, media, telecom and travel, hospitality, and even in other areas also this blockchain technology works. So if you see here this blockchain technology, how it works, they have given as represented in the picture form. Someone requests a transaction. If someone is performing a transaction, the request will be sent to the server, and from here what will happen, the request is broadcast to all nodes in the network. Yes, wherever the nodes are available, it will be sent to all nodes in the network. Once it has been verified by all the nodes, the block gets added in the already existing chain of blocks, and finally will receive a message as transaction is complete. So this is how it works. And here the summary has been given regarding all the concepts which we have discussed regarding artificial intelligence, machine learning, NLP, virtual reality, and about robotics, what is meant by big data and what is meant by data analytics, IoT and WOT, and what is a sensor, finally cloud computing, grid computing, and blockchain technology.
So we have come to the end of the chapter, and I hope you have understood all the chapters which has been explained in detail, and thank you.